and welcome to this, the sixth in the series of AIS developer videos. This one deals with how to map reality. We will be using the App 5 Augmented Reality game. Let's first have a look at the code documentation. As usual, we go to index.html in the root of the Git system, and you will see the link to the code is here, AIS 205 Augmented Reality Game. Now you'll notice this is a slightly different format from JavaDoc. It has a lot more information because we're using Doxygen directly from the Objective-C, which Apple prefers for iOS. Let's have a look at the classes. This is our class list. Here's a fairly simple class, the invader ship. It stores information about the position of the ship in 3 dimensions, its velocity and acceleration. So if it's slowing down, obviously the acceleration is negative. And also the ship health, which tells us how to display the ship, if it's to look damaged or not. Some more complicated classes. There's the Augmented Reality View Controller. Here we go. Now you'll notice that it uses 2 classes. This is a usage diagram. It uses the Reality Camera Preview view and an Overlay OpenGL view. You may remember from App 4, Proximity Advertising on Android, that we created a preview window for the camera, the back-facing camera, and then we overlaid an OpenGL view on top of that with a transparent background. We've done the same thing here. The code looks very different, but the result is the same, and in fact we can reuse OpenGL code across the 2 platforms because OpenGL is a standard way of describing 3-dimensional environments. So that's the usage diagram. You can see a lot of the attributes here, like the laser power bar, shield power bar, player health bar. These are self-explanatory, and these are some of the things, the view controls. Now, this is the first time we've looked at an iOS app, so I'm going to show you how we access, how we run and debug the code on there. What you can see now is Xcode. We're running Xcode version 8.0, and we're running it on a Mac Sierra version 10.12. That in turn is running on VirtualBox on Linux. All development here is done on Linux. We do have genuine Macs lying around, but Apple only supports very, very recent Macs for Xcode. So if we want to write applications for iOS, for example version 8 and version 9, or even now version 10, we need to have a Macintosh built in the last couple of years. Well, we haven't been able to keep up with that, so we've got Macs coming out the years here, but none of them are the most recent, and none of them are supported by Apple for development. Hence, we're using Linux and Oracle VirtualBox, and then Mac on top of that. That's what you're looking at right now. Now, we looked at we're looking at the documentation, and we saw that the key view there, the key class, uses 2 views. It doesn't inherit from them, but it uses them. and in the storyboard view we can see that happening. This is the main storyboard that you're looking at from within Xcode. This is the dialogue that is displayed when the game first starts, and this is the key dialogue, which the window, which is used to actually run the game. And you'll see here it has a view which contains the reality view, that is simply the camera preview window, and overlaid on it is an OpenGL view with a transparent background, and in that is where we display the ships and the explosions and all of the 3D effects. Overlaid on that we have things like the player health bar and the shield power bar and all that sort of stuff, and of course the buttons. So that is the storyboard. The storyboard is just a resource file, just like on Android or Windows or any windowing system that uses resources. Now they're almost all written in XML. This storyboard for Apple is no exception. I will show you the storyboard here. As you can see, it's standard XML. It's awkward to edit in this though, so we edit it in Xcode. Looking at the actual source code while we're here, we're looking at AIS 205 Reality Invaders, and unlike Android, the actual source code is under a subdirectory named the same as the directory. You see, we go the same name twice, and then within there is all of the interesting source code. All the other files are automatically generated. So these are the classes that run the game. The one we were just looking at there was the Augmented Reality View controller. It controls two views, the reality camera preview here, which controls turning on and off the camera, and the overlay OpenGL view, which displays ships and explosions and all in 3 dimensions on top of the camera view. So let's now run the app. Here we are in Xcode. Let's just make it smaller so it fits into your window. Here's that same code again, and let's run the app. Now, to run and debug in Xcode is very similar to how we saw earlier in Android Studio. We can set breakpoints in here just by clicking in Xcode. You see there's a breakpoint there. I won't set one at the moment, but that's the way that it's done. And then we run it by pressing this play button, if you can see it, which actually starts the app. So there we are, we run the app, and now we're looking at the display. The physical device is actually behind me, but you should be able to see it down here in landscape mode, because the app is written to work exclusively in landscape. So we can see the welcome screen down here, and I'm going to show you briefly the edit ship screen. That's if you want to change what the ship looks like, but we don't at the moment, so we'll cancel that and we'll hit play. And there we go. So we can now shoot down saucers if we want to. Or we'll let it get this time. As you can see the saucer, and you can see some damage being received. Yep, it's broken our screen. Okay, game over. We didn't score well there. We'll have another go in a minute. So that's how we run the app from within Xcode. Now, in case you hadn't seen the earlier video about proximity advertising, which uses the same technique, let me just describe briefly what happens. What we do in the app is we have two views, one on top of the other. The bottom view is connected to the camera and shows the camera preview, and then the top view is another full screen view, which is displays OpenGL objects and has a transparent background, so you only see what's written in the OpenGL. We then use the sensors, the magnetic and accelerometer sensors, to work out the precise orientation of the device, and that gives us a camera position and direction in 3 dimensions, which we can then map into OpenGL. OpenGL displays everything using 3 matrices: a model, a view, and a perspective matrix. The perspective matrix we set up by working out where the average user's eye will be in relation to the device. So if it's about 40 centimeters typically from the device, then we can work out what angle their eye subtends when they look at the device. From that, we can work out where we should place the camera in OpenGL space, which direction it should be looking, and how much perspective should be applied in order to make it look like you're simply moving the device around and seeing what's behind it. So that gives us the perspective matrix. The view matrix is how we decide where we are situated in relation to the buying sources. Perspective is how big they look given how far away they are. And then there's a model matrix for each object, such as, for example, the flying saucers, and those are multiplied in OpenGL in order to correctly map the 3-dimensional objects into the OpenGL environment. Now, let's have one more go with the game. I will unplug it now from the development environment so that we can actually see what we're doing. So I'm starting up the game again. Let's change the ship this time. And then play. Now we should be able to see aliens coming in, and this time let's try and shoot one down. Yeah, you can see our score going up. Okay, wave 2, we've shot all them down. Now it's coming in. Okay, I can't see him. Whoa. Okay, he's down here. Oh, he's got us. All right. Well, we made a better score there, 3,600. So I hope that gave you some idea of how we are embedding our device into reality, what we call augmented reality. We use the camera to show what the device can see. We use OpenGL to map into 3 dimensions, and we use the accelerometer and magnetometer to work out the precise orientation of the device in 3 dimensions. Thank you for watching this video, and I hope we will see you again soon. Goodbye.